Now we look at tidal power energy, which can be harnessed from tidal power. Tides or sea tides is a phenomena you see every day when it is caused by the positioning of the Earth, Moon, and the Sun, because both of these have gravitational force. Okay, and actually the Sun is also producing gravitational pull to Earth, but because it is very far, the Moon is the one that is more powerful. And then when the Moon is the part of the ocean that is facing the Moon, uh, the depth of the ocean rise slightly because of the gravitational pull of the Moon. Okay, so twice each day you have this tide along the beach when the sea level rise and drop. There are two types of tides. One is what is called spring tide, or in Malay we call it air pasang besar. This happen when the sun, the earth, and the moon are in straight line, and then they produce the strongest form of the ocean. Then when you have this, then the level of sea rise quite high. Okay, it is called spring tide. Okay, the other form of tides is called neap tides, when the moon is located perpendicular to the earth compared to the line between the sun and the earth. So the tides is not as big as the spring tide, and these normally occur at quarter moons. The use of tidal power is actually not new. As early as 1100 AD, people has used tidal power to do various work. It is as simple as when the tide rises, they collect the water in a pond. So the water level in the pond is at high level when the sea level go down, then they would let go of this water in the pond, and this flow of water will create energy. You can use it for your meal, uh, many other works that need to be done using the pure kinetic energy of the flowing water. In modern times, the tidal wave or the tidal power are being used to produce electricity, uh, and they use what we call tidal barrages. These are basically dams which let uh, seawater in and out, and use the differences in the sea level to run a turbine that would generate electricity. So you can see that when the sea rises, then water would be forced to flow into the estuary, and this would cause the turbine and generator to be turned in certain way to produce electricity. So when the tide is going out, then this water would flow back into the sea, and you would have the movement of the water in reverse. Okay. So whatever movement that is being produced would be translated by turbine and generator to produce electricity. Due to the potential of renewable energy from tidal power, so there was a proposal in the UK in 1980s to do a series of barrages across the 7 estuary waterways in England, between England and Wales. They proposed that the system of barrage would produce um, over 8,000 megawatts of power, and would provide 7% of the energy needs for England and Wales. However, there was a big debate, and they did series of study, both pros and cons of adopting the project. This is part of the task 8 that I gave to you earlier. to see on either side of debate. So eventually in 2011, the ideas was rejected and nothing was done regarding this. But in other countries, in France, they had proceed with such ideas, and some have achieved certain degree of success. So these are the advantages of tidal power. So once you build it, the power is free and it produces no greenhouse gases or other waste. It needs no fuel. It produces electricity reliably compared to wind turbine and photovoltaic, because um, the rising tide and the low tide happens twice a day, and it's not that expensive to maintain. So the tides are totally predictable. Um, and if you have offshore turbines and vertical axis turbines, they are not expensive to build compared to some other technology, and do not have large environmental impact if you build it offshore. Um, as with many other form of energy generation, there are some disadvantages. Overall, even though we said earlier it is not yet expensive compared to other technology, it still is expensive compared to the regular fossil fuel power plant. And the ecological impact of the tidal barrage is of concern. Okay, many birds rely on the tide and mud flats when the tide is low, so ecological damage might be possible. And also there are migratory fish that need free travel up and down the stream. Okay, but the major drawback is it can only generate when the tide is flowing in or out. In other words, about 10 hours each day. Um, when the level between the inside of the barrage and outside the barrage is equal, there's no power generated. Uh, so we can plan to have other power stations generating at those times when the tidal station is out of action. And the problem with seawater, the corrosion that would require expensive mechanical system or machinery for the barrages. So these are some of the disadvantages. Another form of energy from the ocean is the wave energy. Again, if you trace the source of it, it's still solar energy, where the sun creates a high pressure and low pressure region, and then you have wind, and the wind is blowing above the surface of the sea that creates wave. Okay, so even though the wave might change from time to time, but the kinetic energy resulted in the waves still remain on the surface of the sea long after the wind dies down. And in compared to other form of renewable energy, it is most concentrated and consistent, and you have wave round the clock throughout the day. And one of the main characteristic of wave energy is that the higher the wave, the more energy that you would be able to extract from it. This is an example of an offshore turbine to capture energy from tidal wave. So when the current of the sea is moving upward during high tide, so it is like an inverted wind turbine. The blades are underwater, and the movement of the water would rotate the blades, and in turn creates electrical energy. Compared to the barrage system where you have to build dam, this one you don't need dam, so it's cheaper and more environmental friendly. This is an example. This is a simple example of producing energy from wave. It's called oscillating water column. It's just as simple as when there are a wave rushing to the shore, it will compress air, pushing up a small column, and this would run turbine. And when the wave withdraw, it will suck the energy, the wind out of the column and draw it back. and it will turn the other way. Okay, so it will produce consistent uh, energy from the movement of the wave. These are some of the simple example. This one is called LIMPET, Land Installed Marine Powered Energy Transformer. It uses the principle of water column. Okay, it's a simple mechanical principle using the movement of the wave that pushes air through the turbine. And then we have salted duct. The bobbing of the duct or the floating part of the mechanism would create rotation along its axis and would create kinetic energy that would run turbine to produce energy. However, this is not the most popular one because of technical efficiency. A simpler example is what is called tapered channel. So when the wave rush to the beach or the shore, when you have this tapered channel, the water would be pushed climbing up higher level onto a higher tank, and then there is a pipe that let this water run out down to the sea level again, and this would create energy that will be turned into electricity, and this is quite low maintenance and have great flexibility. There are many other technology to tap energy from the wave, such as wave dragon. If you are interested in this, you can just Google it, and I think the development of the technology is fast these days. They have better and more efficient form of this. Okay, you have Palamis. It looks like dragons that float across the wave, and it was developed many years ago. Okay, but we haven't seen this in real capacity these days, maybe because of some technological issues. So the advantages of wave energy compared to wind and solar, it is concentrated over time and space, and it can perform the energy advantage over great distances. Compared to air, water is heavier, and as such it carries more power compared to energy from wind alone. Okay. Compared to land masses used by solar farm or wind turbine farm, it does not require large land masses, and relatively it has minimal impact on environment, and it can help shelter coast and provide calmer water for harbor areas in coastal region, and it can also act as tsunami barrier. Okay, apart from applications of electricity generation, it can use it to produce hydrogen, desalination to get clean water from the sea, can protect shores, can help create mariculture fish farming enterprise. It can be part of the navigation aids. It can be part of a lighthouse. Okay, so as with OTEC, it can produce electricity as well as generate potable or drinkable water. The advantages is of course there. There will be environmental impact from constructing anything along the shoreline, and storm is an issue. Most coastline is exposed to storm, and the machine can be complicated, so technological development is needed in order for this form of energy generation to take place. Okay. And it is not tested. A lot of R&D needed in terms of capital investment, first investment, maintenance costs, repair and replacement, and the impact of biological growth. You have these blisters on growing on the stones and equipment, so that is part